Now, this example from the textbook is wrong. It's just plain wrong. Their solution has assumed that ABCD is a parallelogram. You can go have a look. I mean, the hint is in the question. They said AB is A and AD is D. The next thing they say is that AB and DC are the same vector A. But that's only true if it's a parallelogram. So, change this and delete this. This is not important. Okay? Prove that the midpoints of the sides of a quadrilateral join to form a parallelogram. And just ignore your textbook solution. It's just plain wrong. Let's draw a quadrilateral. And to make it really clear, we'll draw one that doesn't look like a parallelogram. Really important. Okay? Same trick as before. We're trying to trick our brain. Whoops, I already drew a vector. We're trying to trick our brain into not seeing a parallelogram. A, B, C, D. Make it as skew as you can so it doesn't look like any particular kind of parallelogram. I have 4 points A, B, C, D, and I'm looking for the midpoints of the sides. So let's call that P, Q, R, and S. And to make sure it's really clear, mark them as being midpoints. Some people actually go, instead of 4 lines, they draw Roman numeral 4. Don't really care. Okay, I've got 4 midpoints. And I want to look at the lines that join those 4 points. Oh good, it doesn't quite look like a parallelogram. That's good. Won't trick my brain. Okay, I'm using vector methods, so these are also going to be vectors. And because of what I want to prove, I'm going to point them in the same direction to help me figure out what's going on. So, I have a quadrilateral, any quadrilateral at all, and I've got the midpoints of the sides. Well, to show it's a parallelogram, I have to show that this vector PQ is equal to this vector SR. In fact, that's enough. If those two vectors are equal, and they're the opposite sides of a quadrilateral, then the other two vectors must also be equal. But you can prove it the same way anyway. Let's have a think about this vector PQ. The vector PQ I can get by going from P to B and then B to Q. PB plus BQ. But P is the midpoint of AB, so that's a half AB. And Q is the midpoint of BC, so that's a half of BC. Now, let's think about SR. The vector SR is, now I'm actually going to go, which way am I going to go to get here? Oh, SR, I'm going to go via D, okay? It's S to D plus D to R. But S is the midpoint of AD, so that's half of A to D plus, now this one, R is the midpoint of CD. It's half of D to C because I'm going back this direction. And we'll turn it around in a minute, okay? Now here's the trick. A to D is the same as A to B, B to C, C to D. Right, we're going to go the long way around. AB plus BC plus CD. What I've done is replace AD with 3 other vectors that get me to the same place. Now, I had plus, sorry, I was going to change this, wasn't I? DC is the opposite direction from the CD that I want. So I'm going to go minus half CD. Maybe you can now see where we're going. AB and BC are great, okay? Half of AB plus half of BC plus a half of CD minus a half of CD. Oh look, half minus a half. They're going to go away. What have I got left? I've got PQ. So, the vector PQ is exactly the same as the vector SR. There is no other possibility than that these two vectors are also equal. They must be. There's nowhere else I can move this vector. Anywhere I move it, this one and this one are going to be equal vectors as well. So therefore, my parallelogram PQRS, my quadrilateral PQRS is a parallelogram. QED. And unlike the textbook, I've proven it for any quadrilateral, not just for starting from a parallelogram.